Hey, welcome back to AI Simply. In episode 1, we broke down the difference between AI, machine learning, and generative AI. If you haven't watched that yet, go check it out first. The link is in the description. Today, we're going one level deeper, because after episode 1, the number one question I got was, okay, but how does ChatGPT actually know stuff? That's exactly what we're answering today. By the end of this video, you'll understand what an LLM is, how it learns, why it sometimes makes things up, and what's actually happening when you type a message and hit send. Let's get into it. So first, what exactly is a large language model, or LLM for short? Here's the simplest way to think about it. Imagine an incredibly dedicated student who read everything, every book ever published, every Wikipedia article, every news story, every blog post, every piece of code on the internet, hundreds of gigabytes of human written text, all read, processed, and learned from. That student is an LLM. The key thing to understand is this. It didn't learn rules. Nobody told it. A noun is a person, place, or thing. It figured out language entirely by reading examples, millions and millions of examples. And now it can understand your questions and generate fluent, human-like responses, all because it absorbed so much of how humans actually write and think. GPT-3 alone was trained on around 570 gigabytes of text. That's roughly equivalent to reading the entire internet, several times over. Now here's something most people don't know. LLMs don't actually read words. They read something smaller, called tokens. A token is a tiny chunk of text, roughly 3/4 of a word on average. So when you type, ChatGPT is amazing, the model doesn't see 4 words. It sees 7 tokens. ChatGPT is a muz-ing and an exclamation mark. Why does this matter? Because everything the model does, reading your prompt, generating its response, happens token by token. And here's where the numbers get wild. GPT-4 can hold up to 128,000 tokens in its view at once. That's about 300 pages of text it can read and reason about simultaneously. And during training, GPT-4 processed around 13 trillion tokens. That's more text than every book ever written by humans combined. Oh, and one more practical tip. When you use AI tools through an API, you pay per token. So shorter, clearer prompts don't just get better answers. They save you money too. Okay, so the model read all this text, but how did it actually learn from it? This is where training comes in, and it's a beautiful process. Step 1, collect data. Billions of web pages, books, and code repositories are gathered into one massive dataset. Step 2, tokenize everything. All that text gets broken down into tokens, ready for the model to process. Step 3, this is the magic step, predict and correct. The model looks at a sequence of tokens and tries to guess what comes next. If it gets it wrong, the error gets measured, and tiny adjustments are made to its internal settings. Then it tries again. Step 4, repeat, billions of times, over months, across tens of thousands of GPUs running simultaneously. Every single correction makes the model fractionally smarter, and after billions of corrections, it becomes fluent. It starts understanding grammar, facts, logic, tone, even humor would, without anyone explicitly teaching any of it. The cost of this for GPT-4, around $100 million, 25,000 GPUs, months of continuous training. That's the scale we're talking about. So when the model makes those tiny corrections during training, what exactly is being corrected? The answer is parameters. A parameter is a tiny numerical value stored inside the model. Think of it like a microscopic dial that can be tuned up or down. Here's a great way to picture it. Imagine a radio with 1 trillion tiny dials. During training, each dial gets tuned to exactly the right position. Together, all those perfectly tuned dials produce intelligent, coherent responses, like a perfectly tuned symphony. Now here's where the numbers get staggering. GPT-2, released in 2019, had 1.5 billion parameters. That felt enormous at the time. GPT-3 scaled that up to 175 billion, and GPT-4 estimated at around 1.8 trillion parameters. But here's something really interesting, and this surprises most people. More parameters doesn't always mean smarter. Meta's Llama 3 model with just 8 billion parameters can actually outperform older 175 billion parameter models because it was trained on better data with smarter techniques. It's not just about size, it's about quality. Alright, so the model has been trained. The parameters are set. You open ChatGPT and type something. What actually happens next? Let's say you type, "The sky is always." The model doesn't just look up the answer. It calculates probabilities for every possible next token. Blue, 82% probability. Clear, 10%. Dark, 5%. Beautiful, 3%. It picks one, usually the most likely, but with a touch of randomness to keep responses feeling natural and varied, and appends it. Then it does the exact same thing again for the next token, and again, until the response is complete. This is why you see ChatGPT typing out its response word by word, because it's literally generating one token at a time in real time. And here's the key insight. It's not retrieving facts from a database. It's generating what sounds most statistically correct, based on everything it learned during training. There's one setting that controls how adventurous this process is, called temperature. High temperature means more creative, surprising responses. Low temperature means more focused, precise answers. Most applications let you tune this. Now we get to something that affects you directly every time you use an AI tool, the prompt. Your prompt is your input, the message you send to the model. And here's the truth that changes how people use AI forever. The quality of your question determines the quality of the answer. Every time. Let me show you the difference. Weak prompt. Tell me about AI. Result. A vague surface level 3-paragraph response that could have come from Wikipedia. Not useful. Strong prompt. Explain AI to a 10-year-old using a gaming analogy in 3 bullet points. Result. A focused, age-appropriate, perfectly structured answer. First try. Same AI, completely different output, just because of how the question was asked. This skill, crafting better prompts, is called prompt engineering, and it's genuinely one of the most valuable skills you can develop right now. 4. Quick power moves. Be specific about format, length, and audience. Assign a role. Act as a senior data engineer. Give examples of what you want, and treat it like a conversation. Iterate and refine. We're going deep on all of this in episode 3. Stay tuned. Here's something that catches a lot of people off guard when they first start using AI tools. LLMs have no long-term memory. Every conversation happens inside what's called a context window. Think of it as the model's short-term working memory. Everything you've said in the conversation, everything the AI has replied, it's all sitting inside this window, and the model can only see what's currently inside it. Once you close the tab and start a new chat, gone. It remembers absolutely nothing about you, your previous conversations, or anything you've discussed before. It's like talking to someone who has perfect memory for the current conversation, but complete amnesia the moment you leave the room. Now, the size of this window varies a lot by model. GPT 3.5 handles about 16,000 tokens, roughly 12 pages. GPT-4 goes up to 128,000 tokens, about 300 pages. Claude 3 supports 200,000 tokens, around 500 pages. And Gemini 1.5 pushes to 1 million tokens. That's 2,500 pages. The bigger the context window, the more of your conversation the model can reason about at once. Key takeaway: LLMs have zero memory between sessions. Every new chat starts completely blank. And now the most important thing to understand about AI, possibly the most important slide in this entire series, LLMs Hallucinate. That word sounds dramatic, but here's what it actually means. The model sometimes generates information that sounds completely confident and completely correct, but is entirely made up. A real example. Someone asked an AI to list 3 published research papers by a specific professor. The AI responded with 3 detailed, perfectly formatted academic paper titles, with journal names and everything. None of those papers existed. The professor had never written them. The AI invented all 3 with complete confidence. Why does this happen? 3 reasons. First, it's a prediction engine, not a fact database. It generates what sounds most plausible, not what is verified. Second, there's no built-in fact checker. It learned from text on the internet, and a lot of that text contained errors, opinions, and outdated information. Third, it's trained to be helpful. So when it doesn't know something, rather than saying, "I don't know," it fills the gap confidently. This doesn't make AI useless, far from it. But it does mean you should always verify AI outputs for important facts, statistics, legal advice, citations, or medical information. Use AI as a brilliant first draft, then verify. And that's it. You now genuinely understand how LLMs work. Let's do a lightning recap of everything we covered. LLM, an AI trained on billions of documents to understand and generate human language. Token, a tiny chunk of text, about 3/4 of a word, that the model reads and predicts one at a time. Training, the process of predicting text billions of times, correcting mistakes, and tuning parameters until the model becomes fluent. Parameter and a tiny learned value inside the model. GPT-4 has around 1.8 trillion of them. Prompt, your input. The better the question, the better the answer. Always. And hallucination, when AI generates confident but completely false information. Always verify the important stuff. Now you know what most people, including many who work in tech, still find confusing. In episode 3, we're diving into prompt engineering, how to get dramatically better answers from any AI tool with practical techniques you can use immediately. Hit subscribe so you don't miss it. See you in the next one.